The last thing we want to do with scientific notation is to do basic calculations, essentially arithmetic, adding, subtracting, multiplying, dividing. Now, multiplying and dividing is not very difficult to do because you're simply going to multiply the decimal part, and then for multiplying, you're going to add the exponents, and for division, you're going to subtract the exponents. But for adding and subtracting, you have to do a little bit of work first. You have to have the exponents the same in order to start your addition or subtraction. So I find it best to find the smaller exponent and then to convert the other one into a smaller exponent by moving however many times to the right to get that difference. So let me show you what I'm talking about. So in example 7, part A, we're doing addition. So I need to have the same power. Currently, I have a 3 and a 4. So I'm going to take the smaller one and leave it. So I have 2.2 times 10 to the 3. But now I need to get the other term to 10 to the 3. That's only a difference of 1. Going from 4 to 3, that's just 1. When you're going from a bigger power to a smaller power, you're always moving to the right because you're essentially making a bigger number. So that 3.1 will now be 34. Then the next step, once you have the same exponent, is to simply add the non-exponent part. So I'm going to take 2.2 and add 31. And so when you do that, you get 33.2. And I really don't need that parentheses, so I'm going to get rid of it. That's going to be 33.2, and then you keep that shared exponent. Now, often when you do this, you will have to convert back to scientific notation because notice here that I am out of scientific notation. And what do I need to do? Well, that 33.2, I want to make that 3.32. And since that was taking me a decimal place to the left, I'm going to add 1 to my exponent. I know adding and subtracting is a little bit tricky. You have to think through a couple of things that you're doing, and you're never going directly from a regular scientific notation into a regular number or a regular number into scientific notation. You're staying within the scientific notation. So it can be a little bit tricky. You don't have to do a lot of these. There's just one on the homework assignment. It's not a huge concept, but it is something that I want you to feel comfortable doing. So let's take a look at part B. And here I have 10 to the 7 and 10 to the 5. So I'm going to keep the 10 to the 5, and I'm going to change the 10 to the 7. So I need to go 2 units. So I will have to move that decimal 2 to the right, making that 480, and that'll be times 10 to the 5, minus 6.2 times 10 to the 5. At this point, I can subtract. So to subtract 480 minus 6.2, I'm left with 473.8 times 10 to the 5. Now, we do need to turn this into scientific notation, so that's going to take moving the decimal 2 places to the left, making this 7.38 times 10 to the 7. Multiplication and division are much easier. All you need to do is to multiply or divide the decimal part. So for C, it's multiplication, so I'm going to take 4.7 and multiply by 3.2. And that's going to be 15.04. And then my exponents, I'm going to add the exponents. So here it's 6 plus negative 2, which is equal to 4. This is not in scientific notation. I need to move the decimal 1 to the left. And so here I have 1.504, and now that'll be 10 to the 5. Since I had to go to the left, I'm going to add 1 to my exponent. And then finally for division, we will divide the numbers. 9.62 divided by 3.28 And I'm just going to leave the 2 decimal places here, 2.93. And then for the exponents, I will subtract. Be careful here, we are doing 12 minus negative 11. When you are subtracting a negative number, it ends up being the same thing as adding. And this will end up being times 10 to the positive 23. This one stayed in scientific notation, so we don't have to make any adjustments.